Hello and welcome back to Steam It with Steve. Today we're going to unpackage a few more of these historical programming languages that we've been exploring. So let's jump on in. So basically we've got all the way up to COBOL after using Fortran and Algol. And now we're going to move into some of more of the modern sort of era of languages. So let's jump on in. So the languages that we're going to cover today is we're going to do Lisp, then we're going to do Basic, Pascal, C, and then a Java example at the end. So Lisp is an elegant, awesome language. So basically it was the first one that uses lists and allows you to do all these different data structure approaches with it. So to create a list was pretty easy. You just had list and then you put the list. Then you would have different options to manipulate them. So you had the car, the coulda, the cons, append, last, member, and then reverse. So what you should notice there is there's a reverse function that allows you to totally flip the list on its head. So it was a really, really neat language. And basically you would use coulda and car to manipulate those lists to pull out different bits of information. So it was first released in 1960s. It was the first AI language, which is really cool because it was able to use the list to break down the structures. It then introduced garbage collection. So it allowed you to basically create a variable, use the variable, and then once that variable was no longer going to be used inside your code, it got rid of it out of the memory. Now that before that, you would actually have to manually remove variables and save for it to be freed back into memory, which is really, really cool. So it does take a little bit more processing to do that, but the trade-off is awesome. So it saves you a whole heap of memory if you've got all these variables that aren't being used. Most modern languages do that now. The first language then to use data structures, which is was the list that we've covered before. And then it also allows you to express lists really powerfully. So there was a whole heap of stuff that you could do behind the scenes. So there's a bit of a bad joke for you. One of the big drawbacks a lot of people complained about Lisp was the brackets. So basically you had to put brackets everywhere inside of the code. Which did, for some people, get pretty overwhelming. It was a little overwhelming for me when I used to play around with this. But yeah, there's a bit of a joke for you. There's another example just to show you how intense the brackets can sometimes get. So when you write the code, that's what it would look like. But as soon as you put the brackets in, that's what happens. Now, if you use a good modern IDE, so for example, PyCharm, you can see that it's got the rainbow brackets built into it. And that's why something like that is a very powerful tool. So we're going to break off and now do this Lisp example. It's really awesome. Basically, you can sort a list of numbers in one line of code, which up to this point was quite hard to do, but it's awesome. It literally handles all that for you in behind the scenes, and then you don't need to know how to do it. So just pause the video and have a go. Cool. So let's open that up. I've got a newer compiler here because my previous one wasn't working. So apologies for the size on this. So let's go. We'll go write, sort, quotation mark, and then we're going to go to, sorry, don't need commas, 4, 7, 3, 9, 5, 4, 6, 3, 8. Close the brackets. Hash. Quotation. Less than. Close the bracket, close the bracket. Cool. That's a pretty cool ID. It's got the, and then terapre, which looks like a super weird word, but basically I'm pretty sure it means terminal print. Then we're going to go write, sort, quotation mark. Be lazy here. Let's do a copy paste job. And instead of less than, we swap back to greater than. Cool. So we've done this. Will sort it in. It looks like ascending, and then this will sort it in descending. So the swap of that symbol. Let's run it and get it going. Awesome. And that was revolutionary at the time, because if you think back, way back in the day, they've had to use other languages, which you saw before. It just saves heaps heaps and heaps of time, and it was really, really, really cool. So that is Lisp. The next one then was basic programming. So Atari, which was one of the original consoles, allowed you to build your own little programs on their consoles. So they released this programming language called BASIC, and the whole idea was to make programming more accessible for everyone. So it wasn't sort of the dark arts of how does this all sort of work and what's the links. And the idea behind it was to make it as simple as possible so everyone could access it, which is pretty cool. Microsoft actually incorporated this, so they created their first sort of scripting language called Visual Basic, which is what is used in Microsoft Word, Excel behind the scenes when you try and use VBA, for example, which is pretty cool. So this is that language. And if you look at it, it looks pretty clean. So you've got let s is equal to 0, map input v, let n equal a number. If n is equal to 0, then 99. For I is equal to 1 to n. So again, that should look somewhat familiar. We've used that in Nessus pseudocode before. Then let s is equal to s plus s at I. Then next I, then print n, s divided by n, and then go to 5, end. So we had these go to statements 5, which means that it's able to go back up to these points, which is kind of cool. So you had line numbers that you could actually reference, which is kind of cool. It's really neat. So first released in 1964. It was a beginning all-purpose symbolic instruction code. That's what BASIC stands for. Programmers never like keeping things simple. And then it had a general purpose language that was trying to make it a bit more accessible for everyone. So it's a high level programming language. What high level means is it's not as close to binary with the zeros and ones like Fortran that we saw originally. The idea is it becomes more English based. The syntax looks a bit more structured. And yeah. It also made it easier to create a loop than Fortran, because you can see how easy it was to make a loop here. So for I is equal to this, and then have the next I underneath, that should look very similar to the Nessus pseudocode we've covered. Cool, so we're gonna make a real simple basic example. This is a game called FizzBuzz. If you ever seen those sort of Google interview questions that they try and get you to do, this is one of those sort of famous ones. The idea behind FizzBuzz is you're basically going to write a program that prints out the numbers from 1 to 100. But then for multiples of 3, that it prints out fizz instead of the number. And for multiples of 5, it then prints out buzz. And then for multiples where both 3 and 5, then it goes fizz and then buzz at the same time. So have a go at that. Open up the tutorial, pause the video here, and see how you go. Cool, so let's open that up. Let's build FizzBuzz. Just check that this compiler is working. Great, that's what wasn't working in Lisp before, and I had to go off and find one. So we're gonna go for I is equal to 1 to 100. And S $ equals brackets. If mod of I 3, then equals is, and the if, that's what the v means at the back there. If, and so it's a legacy one that we saw before, mod I of 5, then $sign, where are you? $sign equals whatever the $sign was there. So then this allows us to do the buzz if it is a multiple. So for example, 15, without having to write a separate thing. So see how we're doing the postbox version of an if statement here. And then B, so that's the end of the if statement. And if x $sign equals nothing, then I else. So you'll just use I as normal. Otherwise, we're going to go and use the v else s $sign and the if. sure why that went orange, but that's all good. These things happen. So hopefully you got 4. I is equal to 1, so 100. Stores the output for string. If the mod of I and 3, then the $sign is equal to fizz, and then that's the end of the if statement. Then if it mod 5, then you add on buzz. So if it was blank, you would just have buzz if it was 5, for example. But then if it was 15, it allows you that jam buzz on the end. And then if it was blank at this stage here, so these are the two sort of checks. So then it basically checks if it's blank, then it's I. Otherwise, you put in the $sign into it, which is pretty cool. And then there's fizz buzz working. So 1, 2 fizz, 4 buzz, fizz, 7, 8 fizz buzz, 11 fizz, 13, 14 fizz buzz. Pretty cool. So hopefully that's giving you some ideas on basics. Now there's a whole heap of different ways of doing it. There's a little link here that shows you 5 other ways that you can do fizz buzz. So you can do it in Scratch. There's an example. There's the smallest one that I found, which was done in 51 bytes using this very special, sort of more exotic programming language. And yeah, so that should give you some insight in how fizz buzz works. The next one that we're going to look at is then Pascal. So Pascal was sort of the next iteration onto these languages that sort of extended it. And what you should see with this code is it starts doing typecasting of variables at the top. So you have age, name, and messages. And then you say that the different data types that you want to use. And then you've got this real clean sort of indentation happening and just makes the code look a little bit cleaner. So it was released in 1970s, expanded on the features of Algol, and it was very successful for microcomputers when that came out. It's a very clean language to use. So compared to other languages that came before, it still had the power of Algol, but it made it a little bit easier for users to sort of operate with. So one of the things that you might notice here that's a little bit different, instead of just equals by itself, use colon equals for any assignment. So this is what an assignment character looks like. And like I said, every language has a different thing. You also notice that there should be semicolons at the end of each statement. So then that signifies that that's the end of the statement. So an if statement actually doesn't finish here, it finishes down here. And then that's how the compiler is able to read and go, oh, yep, if, and then it keeps going until it finds that semicolon at the end. The compiler was really, really fast as well with this. So that was a huge advantage to using Pascal over others. And it was a high-speed program with very low memory use, which a lot of people sort of lent into. And then it started introducing a concept called object-oriented programming, which is what we saw before when we did the snake example, and made the structure sort of using attributes and then methods underneath to have that real sort of clean link between them. So here's a Pascal example that's going to print out the minimum number of 3 numbers. So it's going to put in the 3 numbers and then find the minimum using a procedure. So what you should see here is there's a program, and yeah, pause and just see if you can build that little bit of code. Cool. So let's open that up and let's build it. All delete. And we're going to go program x procedure semicolon var. I'm going to define the variables. So we've got A, we've got B, we've got C, and then min. Then we're going to say the data type that they all are in one line. So they are all integers. Now the advantage of doing that is for memory. So by doing that, it's very clear that these are all variables that need to be used and also stored. Then we're going to build our own procedure. So we're going to go procedure. And we're going to go find min, x, y, z. And these are all of integer types. On there. Semicolon. And var m needs to be inserted as well, which will be the min by itself. So this will be an integer as well. Semicolon. So the procedure has now been defined. And then this thing finds the minimum of the three values. Here we go. So we're going to go begin. If x is less than y, then. And then underneath this, we're going to keep going with statements. So notice that you don't need to use the snaky bite. You just use then. M. And then this is very different. We go colon equals, which is the assignment operator, is equal to x. Then underneath here, we're going to go else. M gets assigned to be y. And then semicolon. So that means that's the end of that if statement. If z is less than m, then m colon equals z. And then that's the end of that procedure. So that procedure now goes end. Bracket. End of procedure. And min. Cool. So that's kind of like what we've done in Python before. These are all the different functions that need to be sort of written out up first. We've got the global variables up here above it all. And then underneath here, we're going to actually write the main line. So for the program X procedure, we're going to then go begin. And this should look familiar. We're going to go write a line, so ln, enter three numbers, colon, and semicolon at the end there, sorry. And we want to read in lines. So we want to put in an A, a B, and then a C. Then we want to find the min of A, B, C, and then the minimum value at the end. That's going to compare them all. And this is the comment, so we're going to say that this is a procedure call. And then at the end, we're going to write the line minimum colon and quote, comma, min. That should look very Python-ish as well. Then at the end, we end it. Like 24. Ah, that's good. So three numbers, we're going to go 4, 6, and 9. And it spits out the minimum and gives us a 4. Pretty cool. So what you should see here is we've got the procedure, name of the function. So instead of def, we go procedure, name of the function, then all the different parameters. You need to say the types of the data that's going to be done. The reason this is done separately is because this is going to be the output. Because at the end, we want to make sure that they're going to be able to access M to be able to find the min. And yeah, so once min's been created, that's now accessible anywhere. So min, this is where it's a little bit funky. So this is sort of your return statement, but it's been built into the procedure at the top, which does get a little confusing. But as long as you put the var m, what that means is this is then accessible outside of this function, which then sort of gives you a bit different sort of take on how scope works. So that's a pretty cool little example of Pascal. The next one then is the big dog. So C is amazing. C is one of those languages that have been around for ages. All your operating systems, they still sort of run on this language. And yeah, it's pretty cool. So this is the way that it looks. It's really, really, really fast. So it's able to convert down to zeros and ones into the machine code really fast. That's the huge advantage. And what you can see here, some of it should be making sense to sort of scan reading through it. So include is the same as import. So import this library, which is the standard input and output library. You then have your main function. Instead of indentation, you can actually use curly brackets. Then you've got int I num p is equal to 0. then printf, scanf, for loop, and then if this is true, do this, and then if p is equal to 2, you're going to do this, and then else you're going to pop that out. So it was developed in 1973 from B, so that was the original language by Dennis Ritchie. It's an imperative language, so it's really, really fast. It's designed to work with memory, and it's really efficient with the way that it does that. It makes it very fast when running. So and it's also been made so that it's portable to different systems. So the engine that it creates is very sort of user-friendly, that you can swap over, and there's no need to define items. You can also typecast them to swap them around. So if you define them as an int, you can then typecast it to swap that, which is very cool. And just to reiterate, it is very, very fast. So here's a little simple example similar to what we just did before. This time we're going to find the minimum 3 numbers, but this time we're going to use a concept called recursion. Now this is really neat. Basically, it's where we use a function inside of a function. So just pause the video, type that code out, and see how you go. Cool, so let's go and build this. Delete all that. First step is I'm going to include the standard input output library. Then I'm going to make a function, so it's a long integer. It's a really big number. Multiply numbers, put it in int n, semicolon, and then now we have our main line. So we're going to then go int main brackets, open bracket. We're then going to go int n statement. So that's what the semicolon does. Printf, and we want to print out enter a positive number, integer, sorry. Close the brackets, put a semicolon, scanf, then %d, comma, the ampersand symbol, ampersand n, bracket, semicolon, then printf, bracket, factorial of %d is equal to %ld. Quotation marks, comma, where we're going to put in n. So this is formatting as well. Sorry, that's what printf does, means formatting this text. And we're going to put it into it, multiply numbers, n, and then at the end, return 0. This main line has a return value, because otherwise it freaks it out. Then we're going to go long int, multiply numbers, int n, open brackets, and then if n is greater than or equal to 1, return n times, and it's going to call itself multiply numbers. That was pretty cool. Press tab, n minus 1, else we're going to return 1, semicolon. So then that's the base case. So this thing here is going to do, sorry, this isn't finding the minimum. This is finding the multiplying numbers together and finding factorial. So let's run this again. So line 14 doesn't like that. We're done. Line 14. So return. Let's run that. Enter a positive number. So let's go 3. Yeah. Doesn't like it. running. Okay, let's try again. Stop it. Give it a space. Factorial %d equal to %ld. Comma n. That's looking pretty good. Let's run that again and see what happens. It's compiled. There we go. It's online and it's running a little slow. So there you go. That worked. Now, just so you can see that works again, we'll go run. Type in a positive number. Let's go 3. Keep it small. And then factorial 3 gave us that. Then if we want to do a little bit bigger, so 111. Way too big, so then it freaks out. Because a long integer wouldn't be able to store that. Because that would be 111 times 110 times 109 and so on. So I reckon 55 is probably a big one. Yep, and that was able to handle it. Now, just to show you something so that you've seen it, going to be a bit of an indentation terrace here. How cool is that? So this is why this language works, because of the colon, the curly brackets, and then the statement symbols. It does not care about indentation. So you can have something weird. You can even do stuff like this. You want to be really all over the show, and put that there, which is probably messing for you guys a little. Now if we run that, my code still works. Okay, so this is why some people sort of get the head spinning with this. The idea behind this is it's because of the statements. So every time you put the semicolon at the end, it knows that that's at the end. So your indentation doesn't need to be perfect with a language like C. Now, is that bad practice? Absolutely. And that's why I love teaching Python to start, because then you learn how to sort of line up your code perfectly. And then when you see like this, you probably should be triggered because it's all over the show. Cool. Last one we're going to do is Java. So Java is awesome. This was the first sort of main language that I learned over about a year. Heaps of stuff that goes with it. It was actually originally released in 1996 for cable boxes, so for using satellite TV. And the idea was to try and build something that's super lightweight, but can work on a whole heap of different devices. So the big difference with Java is that it held 5 separate principles. So first of all, it must be simple, object-oriented, and then familiar to all the different languages that we've done before. It must be robust and secure. It must be architecturally neutral and portable, because remember his intention was to be built for cable TV. It must execute with high performance, and then it must be interpreted, threaded, and dynamic. So it was object-oriented programming language, and it worked on any device because what happened, it used this thing called the Java virtual machine. So basically what happens is you would install an application called the Java virtual machine, and then your code would be injected into that virtual machine to run. So the virtual machine would be able to work natively on whatever device, so if it was Mac, PC, etc. And then this sort of gave the foundation of something like Unity, that's able to work on many different devices, all from one source point, because that virtual machine is running in behind it all. The downside is that it's not as fast. So because it has to go through this virtual machine first, it's not as efficient depending on the hardware that you're working with. So that's why something like C is still superior in this case. So we're going to build this little program here, which is a leap year program. So it's going to go through and check to see how many leap years, if it's a leap year or not, and then give that output to you using Java. Java loves using classes. So classes are everywhere in Java. You have to use them to build the code to start. And the main line always has this phrase, public static void main strings brackets args. And hopefully you can tell by my voice, that was sort of drilled into me. That's just the process that you would write for any program to start a Java program. Cool, so pause the video and see how you go. Cool, so let's open this up. let's build a Java program. Done this for a while. So we start off with public class. So public means that everyone can access this no matter where it lies. So it's very, like we talked about, security is very important and making sure the code knows the scope of where everything is. So then we're going to have public static void main string brackets args. Haven't typed that for a while. And then open brackets. And then now we're going to build the code. So we're going to go int year equals 1900. Then boolean leap is equal to false. No, so it's lowercase false. Then if open brackets year mod 4 is equal to 0, open the brackets, and then comments of // year is divisible by 400. Hence, the year is a leap year. Then if the year, and notice how the if statements always have parentheses around it, year mod 400 is equal to 0. Well, we don't even need to do that, sorry, because it's just a one-liner. So that was another neat feature with Java, is then you just literally say leap equals true. Else leap equals false. So because they're just one-liner bits of code, you don't need to write more than that. So we've done that. Oops, I forgot one if statement, sorry. So if year mod 100 is equal to 0, notice double equals it as well. Open brackets. Paste. There. Hopefully this ID allows me to do it. Yep, cool. So just press tab. And then I've got leap is equal to false. And then underneath this 100 one, I'm going to go else leap equals false, colon. And that's that. I'm going to change this code a little. I personally like writing my brackets like that afterwards, so that I know that this if statement and this indentation is that attached to that, and this is attached to this if statement, and then this is attached to this if statement. So else leap else. Sorry, that should be true. Else leap false. Should be that done. Cool. So now we've got the main line done. We now need to output if it is a leap. So if it is a leap, instead of print, this is where it gets a little bit more complex. You're going to draw from the system library. You're going to use the out area, and then you're going to use print line year plus is a leap year. Else system.out print line, going to print out year plus is not a leap year. Cool. And then we'll just need to put a space up in there as well. And then execute. Two errors. Whoops, forgot my semicolons. Too much Python lately. So that's got semicolons. Yeah. Cool. So 1900 is not a leap year. So then let's do 2000. Is a leap year. 2001. Not a leap year. 2002. 3, and then 4 because of good old Olympics. Cool. So that should show you that, which is pretty cool. So Java, still used today, one of the more popular languages, and it's awesome. Very, very powerful, very secure, and yeah, can be used on a lot of different devices. So still quite popular today. That's back in 2019. I think Python's a little bit more popular now because of all the machine learning sort of stuff that's out there. But yeah, so some conclusion questions you should be asking yourself: how can understanding different project management tools benefit the projects? Oops, these are old questions. The other thing that you should be thinking about is how does these different languages sort of connect? So hopefully that's given you some insight into the different languages, and you've enjoyed that. It should hopefully give you some context of how Python is awesome, but also where it drew all the sort of inspiration for how it sort of came together. If you do have any questions, please pop them down below. And yeah, don't forget to like and subscribe because it does help with the YouTube algorithm. And we're trying to grow this so that people can learn Python for free, have some interesting experiences, and yeah, just get involved with computer science. So thanks again. See you next time on Steam It with Steve. Adios.